Good morning and welcome to our chat today for the 3D printing specialization, which is being offered on Coursera. So this chat has been set up in the second course in the series, which is 3D printing applications. My name is Vishal Sachdev. I am the instructor for that course and also helping set up the entire specialization. I'm also the director of the Illinois Maker Lab at the University of Illinois, which is the world's first 3D printing lab set up in a business school. Then we are fortunate to have with us Andrew Lam, a consultant in development and disaster relief, particularly focused at how technology can be applied in the field. And so, the firm he also works with, Field Ready. And we are going to get his perspectives on how digital manufacturing, in any form, not just 3D printing, can enable response to disasters at scale. Thank you for joining us, Andrew. Could you introduce yourself first?
Yes, certainly. My name's Andrew Lam. The way I got into this was through my involvement in a disaster relief organization called REDAR, which does a lot of training for humanitarian relief workers around the world. And I used to run an organization called Engineers Without Borders here in the UK. And essentially, one of the things I became quite interested in is the idea of large numbers of small-scale, distributed, decentralized technologies that could empower people to determine their own development. So with REDAR empowering individuals and Engineers Without Borders empowering individuals, it was a natural fit to then look at some of the more innovative technologies that are out there. I was approached by Field Ready's co-founder, a relief worker called Eric James, who was also on the board of REDAR at that time. And he had more than 20 years worth of experience, has more than 20 years of experience of doing frontline relief work and program management for a variety of different large organizations. And well, he basically convinced me with a problem, which is that the logistical supply chains that aid agencies use when they try to respond to a disaster, to help people affected by a disaster, are the bugbear of a lot of aid workers. A lot of aid workers can't do their jobs because they don't have access to the things that they need to do aid work. His idea was, could there be a way to use 3D printing, digital fabrication to make supplies in the field? And that is a very, that idea was, fitted with my my sort of philosophy and the ideas, some of the things I've been working on. That's how I got involved in this.
Okay. I know, disaster response, it seems that, a distributed technology that's available to leverage in the field would certainly work. But give us a sense of what the problem really is when you face a disaster in the field, and perhaps how, what's the mission behind Field Ready in trying to address this issue? And then we can talk about how 3D printing comes into play.
Okay. The problem really is that after a major disaster, particularly in a context that isn't well prepared for it, say, in Nepal last year, just over a year ago, a major earthquake, the building codes weren't up to scratch. Nepal is, although a very rapidly developing, it's a very poor country. It wasn't very well prepared for the earthquake. and so an awful lot of the infrastructure was destroyed. When an earthquake hits, it destroys a lot of the key infrastructure, and certainly a lot of the livelihoods of people in the affected area. And so in Nepal, they had problems actually trying to get supplies to people, basic supplies, by which I mean things like shelter supplies, tents, stoves, blankets, things like that. Up in the mountains, it can be very cold in Nepal. But because the earthquake has damaged all of the infrastructure, it's very hard to get those things there. And so even after what might be a very, very, very long supply chain, trying to get things to the international airport, say, or across the Indian border or the Chinese border into Nepal, they still had severe problems getting the aid out into the villages. You're talking about, trying to navigate the Himalayas here. It was a phenomenal supply chain problem. And so the problem was essentially the effect that had. People weren't getting what they needed to survive. And I think there's an awful lot of criticism of the way the aid response worked in the Nepal earthquake and some of the back barriers it's still facing. But actually, it's a very, very difficult context to work in. So the fundamental problem is one of survival after a disaster, but then also reducing vulnerability to disasters, to these sudden shocks that can destroy the infrastructure. And obviously, the way I've told that story, you can see how it relates to supply chains.
Yeah. So specifically, perhaps on the Nepal case itself, I remember reading about some project that Field Ready had tried. Could you share details of that story?
Yeah, we've been active in Nepal for, I would say, fully active for about 7 months now. We did an initial assessment trip a few weeks after the earthquake in May last year, and we basically found that the time wasn't right. There was a lot of confusion, and trying to innovate in that context would have been very challenging for what Field Ready is still a relatively new organization. We went back in September and found that actually there was a kind of, the space was suddenly available, that the immediate needs had been met, and the question now was attending to the ongoing needs of the affected communities. So we did a couple of assessment visits to different areas of Nepal. One of the things that really came out very clearly from a lot of aid workers, from a lot of people living in IDP camps, the displaced people camps, in the worst affected districts of Sindhupalchak and Gorkha, was it sounds really strange, but actually water fittings was a big problem. They were having to improvise a lot of water fittings, and let's put this in context. Nepal, a very poor country, a lot of people are living off pipes that are pushed together anyway, but now people are being concentrated into temporary shelters rather than being able to sort of develop their own housing. They're being collected together because of all the rubble elsewhere. So they're in these very high density camps, and water and sanitation is a big issue. So you want decent water fittings to connect all the pipes together. And they were having to improvise a lot of connections. So one of the things that I did with my colleague Mark when we were out there was a quick proof of concept of making water supply fittings in an IDP camp that that are basically not available on the local market, and that are a much better way of connecting pipes together. We went back in December when we started our sort of longer term program there, and the fitting that we'd made was still operating, still working very effectively, and a lot of people were asking, how can we do more of this?
Okay.
And since then, my colleague Abby Taylor, our Nepal technical coordinator, our program lead out there based in Kathmandu, but working in the districts. She's been doing all sorts of incredible work with 3D printers and 3D printing molds to do a bit of injection molding of parts. So electrical items getting the power into clinics restored by 3D printing new covers for electrical sockets, improving communications amongst the very deep valleys that they have in the foothills of the Himalayas by designing a helical antenna, which is basically constructed out of some wire, some poles, and some 3D printed connectors.
Okay.
We've been doing a whole variety of things, lots of support on the medical component side. Spare parts for baby warmers, incubators essentially, that have been used in hospitals. But the hospitals in Kathmandu get a lot of donated equipment from richer countries, and after a while, when those products aren't made anymore, they're still using them, and they have to make their own spare parts, and we were helping them to do that.
Okay. I know one of the things, that's probably, I noticed in your conversation is a lot of it is being driven by your team. How do you get this out into the field so that you empower the people there to, and I think you mentioned earlier also the issue of response time. So I would think you need to figure out a way to empower the people in the field to leverage this technology. Any thoughts on how you address that challenge, or how you're trying to address that challenge?
Yeah, this is actually a really exciting area for us. There are some business models that we're exploring for Field Ready. Our purpose is to try and solve problems in logistical supply chains in disaster relief. We don't necessarily want to be a supplier to either of 3D printers or of the things that 3D printers make to aid agencies. So a lot of what we do is training and the capacity building of local talent, local makers. They tend to be sort of engineering graduates, and getting that skill set trained up to use 3D printers. Now, I should say the context of this is before we were operating in Nepal, we'd done a pilot in Haiti. And what we found in Haiti is actually that whilst there were people in Haiti who were okay at making things, the level of IT literacy, of being able to use computer-aided design software, was actually quite low. I guess in the universities in Haiti, they don't have sufficient access to computers or to the software that they need to make stuff, to design stuff. In Nepal, the situation's a bit different. The talent in the local population when it comes to 3D design work is extraordinary. Really, really high quality.
That's interesting.
Yeah. But the problem at the universities is that there's perhaps a shortage of tools, and so they've got computers, but they haven't got necessarily the tools. And where tools are donated, big machine tools, they tend to be big machine tools that you might find in a machine lab in a laboratory in America or the UK or something like that. And sometimes the students aren't allowed to use them. basically, there's a lot of, because there's restrictions over it.
Yeah.
So essentially, you've got this latent desire from a large number of engineering students, very highly trained on computer design, who want to use 3D printers. So we've been working with a few and training them up. And the area where we've needed to train them is essentially, this is how to use a 3D printer. That only takes a day. It takes a little while to get used to some of the subtleties of the orientation of the different parts that you might want to print and things like that. But the main focus of our training there has been problem identification.
Okay.
And figuring out what is appropriate to be printed on a 3D, to be made on a 3D printer, and what might be made with other tools. And we've been focusing on quality control. That's a really, really big issue. Now beyond that, in the longer term, what we're hoping to build is a network called Humanitarian Makers, who are humanitarians that can make things. But our approach to that is trying to recruit makers and train them as humanitarians, rather than recruiting humanitarians and training them as makers, which are other. And then in the longer term, in terms of business model supporting all of this, we've got an idea called the Internet of Production. The concept is essentially the Internet of Production, or the MakerNet. We've nicknamed it the MakerNet. Is this idea that, from Field Ready's point of view, the challenge is, after a major disaster, you need very high volumes of supplies. So you might, one aid agency in Nepal might, so I think it was Save the Children, brought in about 200,000 buckets into Nepal. 3D printing a bucket is probably not the best idea in the world. You'd be doing a very long time. 200,000 of them, it will also, that is not the way to go. So the question with the Internet of Production is an idea about, well, can we find a way to use, let's say there's a future in 5 years' time where metal 3D printers are commonplace. Can we metal 3D print molds for buckets, which can be distributed to, say, 50 local bottle making plants that might make plastic water bottles for a living, and their injection molding machines could be repurposed to make, say, 4,000 buckets each, so that aid agencies can then order 200,000 buckets from the local market, rather than saying, making them, say, in China or in Pakistan, stockpiling them in Copenhagen, flying, or in Dubai, and then flying them into New Delhi and then trucking them into Nepal. Can we actually support the local market? And what's needed there is an interface between the big and the small, between the distributed manufacturers and concentrated, so distributed supply and concentrated demand. And we think there is value here in the idea of an Internet of Production.
I think that's a great idea. I think we've seen, a couple of the things that you're describing in these field locations. We see that happening in the lab as well. There's a lot of latent demand that's not able to leverage these tools. Engineering students, they have labs that are purpose specifically for class projects or for high value projects, and then they don't have the ability to experiment and fail cheaply and then innovate. So I think that's the space we filled out with a open access, community based, cheap FDM based desktop printers, which and people come up with amazing stuff.
Absolutely. And actually, interesting. And so that idea is something we're trying to get involved in the field. So actually, by deploying this kind of distributed manufacturing technology, digital fabrication, 3D printers primarily, one of the things we've been able to do is actually identify local needs that, quite frankly, couldn't be met
Yeah.
in any other way. And certainly being able to find items like the corner of a baby warmer for a hospital in Kathmandu, a baby warmer that isn't made anymore, there's no spare parts supply chain. It's not in any aid agency catalog. If you want that thing to work, you're going to have to improvise something, and generally what they were improvising there wasn't hygienic.
Yeah.
So this wasn't in a catalog anywhere, but we took a functioning corner bracket of one of the baby warmers, one that wasn't broken. We knocked up a 3D model of it just by measuring it by hand, with all the nooks and crannies. And then we were able to print out a copy, test it out, and do a bit of rapid prototyping to make sure to improve the design, make sure it didn't break again. Now, you can find that design on Thingiverse, but you can't now because we've shared it, and that's the value of open. But actually, you wouldn't find that in an aid agency catalog, and you wouldn't be able to. You wouldn't find that certainly on a formal market. So that in those areas at the moment, there is big potential for 3D printing.
I think the grassroots innovation, or enabling grassroots innovation, we've seen several stories like that out of the other project, which our learners also get introduced to, which is the subsistence marketplaces project, where we've got, allowing low literacy, low income consumers to become better or smarter consumers and participate in a marketplace, or perhaps let them understand how a marketplace functions. And to add to that skill, we are looking at 3D printing as an sort of a step to make them producers as well, and solve local problems.
Yeah, and that's really where the Internet of Production idea begins to work, because you do need a critical mass of talent, and you need to be able to have a reliable quality control, which goes to the talent point as well. In theory, if you had 50 different factories or maker spaces in Togo that all had similar printers, you would be able to share a design and be able to get very rapidly larger quantities of a particular item without international supply chains. There would still be some local supply chains involved. But again, that supports the local market. I think that there is, you can walk around any town or any disaster affected community in a developing country, and there are plumbers and electricians and carpenters and metal workers and welders and roofers, and there's builders. There's an awful lot of local talent, and the question is how can we, at low capital cost, create good jobs so that they themselves can sort of add value in their work and deliver higher quality, on a reproducible basis, and essentially move them from being laborers or consumers to creators. And I think that's a very powerful concept of what the future of employment in developing countries might look like, because there is a lot of these countries are facing huge demographic changes with the growth of people under the age of 25. And you're not going to be able to get all of these people working in a factory, no matter how much you might try and encourage Toyota to invest in your country. You're not going to be able to employ them. The answer is you've got to help people to do things themselves, I think. And by the way, people who create are happier than people who consume.
Absolutely. Yeah, I think we see that. I mean, one of the objectives of setting up this course and, creating a beginner level curriculum, and, learners are going to learn software and 3D modeling skills. The software has become more and more accessible and, and free in most cases. And it works without very high-end computers now. I mean, it still requires something, but it's not that resource intensive.
Yeah.
And with a lot of the open source projects around the hardware, it is possible, you know, to have a $2-3, you know, maybe $200 kit, which can serve some basic purposes and can be assembled by people in the field.
Absolutely. And I think, so on the software side, in Nepal, we don't tend to have a problem with design.
Okay.
We can recruit local people to do the design work. But certainly if we're trying to work with aid agency staff are trained to be aid workers. They're not trained to be manufacturers or makers. So we've been looking at, with Imperial College in London, and they helped us to develop some software where you can, it's in beta version at the moment, we're testing it in Nepal, where you can say, I've got a pipe of this size, I've got a pipe of this size, and get the software to automatically design a pipe fitting that will connect the two of them together.
Nice.
So you don't have to design each one in turn, and it will parametrically design the fitting.
Yeah.
So increasingly you're able, I mean, and Enable, I know a great group that have been working on 3D printed prosthetics. They have some work with Autodesk to look at the parametric design of prosthetics. So there's an awful lot of automation options there. Obviously there's sharing designs and things like that. I think what was the other part of what you said? It wasn't just software. The other thing is
hardware, the open source.
The open source side of things.
Yeah.
One of the big problems that we have in the world at the moment, I would suggest, is that it's very hard to share know-how. Yeah. Data, open data and open knowledge is reasonably easy to share on the internet. Wikipedia and all of the world's open data platforms are testament to that. But it's very hard to share know-how openly, to show someone how to make something.
Yeah.
I'm on the board of a foundation called the Apropedia Foundation, which runs a website called Apropedia. It's like an appropriate technology Wikipedia, but it's called Apropedia. And it has all sorts of information on there on know-how, helping people to know how to make appropriate technologies themselves. And it's a very, very busy website. It's used a lot, particularly in developing countries. But actually, there's also a hell of a lot of use of YouTube. You know, I think a lot of people, a lot of the learners on this course will have at some point gone to YouTube to learn how to do something with their hands.
Absolutely.
To learn how to, in my case, to tie a bow tie, but you know, or to fix a piece of IKEA furniture or something. But anyway, we need to get better at sharing know-how openly, and that's a real challenge for all of us who have got access to education and have the space to be able to share what we've learned in richer countries, to be able to not just share know-how. I mean, it's very hard to get an engineer to write how they did something.
Yeah.
It takes a long time, but that's going to be the next big challenge is sharing that, and courses like this really help.
And on sharing know-how, I think one of the learnings from our other projects where we're working in the field is also that there is a lot of know-how in the field that needs to be captured and exposed to that context, or perhaps similar contexts in another country, which are solutions far better than what you and me sitting perhaps in an ivory tower can even think of as to what's relevant for that context.
Yeah, I mean, one of the things we're talking about with this software for pipe fittings is like what we're trying to do in an IDP camp in Nepal, of using this software to 3D print water fittings. You know what? Let's try and do that in London. Let's try and bring that technology and learn how they're doing it over there and bring it to London. Because the more you can get rid of supply chains, the more efficient you can just focus on the movement of raw materials, the more you can add value in the local economy, bring back manufacturing jobs to the UK, to London, and have makers around the world. And actually, I would really rather my house or the place that I live in was built in a similar way to some of the Earth's structures that they have in Nepal, as long as
Absolutely.
they're earthquake resistant, because they're just so much better at dealing with the climate.
Absolutely. Yeah.
Yeah. So we've got a lot to learn both ways, but sharing that know-how is going to be a real challenge for the next generation of engineers that are coming out of universities and coming out of courses like this now. So.
Great. So with that, let's open up the floor for questions. We have folks from Bangladesh, India. At least those are the ones who have introduced yourselves in the chat.
The question is, in Bangladesh, the technology is still unknown and new. Getting 3D printing technology to come there. I would say that a very powerful way to do this is to join, or to join a community that I've been involved in, called the Global Innovation Gathering. The Global Innovation Gathering is a network of maker spaces in developing countries around the world. And I'm afraid I can't remember their web address, but I'm sure if you look up Global Innovation Gathering, you'll find something. And the point about this is that if you and a few friends are able to get together and set up a maker space in a place like Bangladesh, it doesn't need to be a particularly grand thing. In fact, the more accessible it is to people, the easier it is to grow. You can have a few 3D printers, a few computers with some design skills, and the Global Innovation Gathering will be able to share some experiences about how they've developed their their strategies, their business models for supporting those spaces in developing countries. They have a project called a hub in a box, which is actually quite interesting to look at. So check them out. But the other part of it is that from a field ready point of view, it is worth speaking with your university or with your, if you have any links to people who work with international aid agencies, that might be a way to reach out. And certainly getting in touch with me at Field Ready, I'd be able to find out which aid agencies that we know of are operating in Bangladesh on disaster preparedness work, that we could bring this technology and figure out how to use this technology to support supply chains there. Great. I hope that answers your question. Is there another one we should go for?
I don't have any. I just wanted to add. Oh, there's one from Mehboob only. In terms of what do you think about the printer material as it's hindering the economies of scale? In terms of those materials are also not environmentally friendly. Any thoughts on alternate materials which are more sustainable?
Yeah, I have a sort of a bit of a problem here in the sense that there is some fantastic work being done by groups like Tech for Trade and several others on the idea of using recycled plastic to create 3D printer filament. One of Field Ready's decisions has been to make sure that we use sort of proven commercial technology rather than the more sort of cutting edge experimental technology that's being developed by groups like Tech for Trade. So until there is a commercial plastic recycler on the market and we can recycle local supplies of waste plastic, Field Ready is going to stick to ABS and PLA. And because of the context that we work in, international disaster relief work, the nature of that business is that there's always aid workers flying in and out. So putting some reels of plastic into a shipment or into the bags of friends and colleagues in aid agencies is how we're solving that problem at the moment. it is you picked up on an important challenge for us though, because the last thing we want to do is to replace supply chains of finished products with supply chains of raw materials. Our purpose is to try and get rid of supply chains altogether so that things can just be made locally. But, you know, not every country has access to raw plastic. And yeah, I mean, I think there's all sorts of projects. I see here that, Vishal, you put Protoprint in from India. It's a really promising area of work. The way we're using recycled plastic at the moment is through a material called polyfloss, which is a bit like candy floss or cotton candy, as you might call it in the US. But it's made from recycled plastic, and we're trying to look at using that as an insulating material. Okay. The economies of scale question, it's about basically switching from a 3D printing process to using 3D printing to make molds, and then you're using recycled plastic to fill those molds, basically. That's how you reduce it. In terms of hemp and algae as a base material, we've not got experience with that. We do use ceramic, we're experimenting with that, but I'm afraid I can't answer your question there. But so I'll answer Shivam's question. The recent 3D printing technology at a personal level are not much developed to be fast and reliable enough to provide an end user product. I would tend to agree, except if you're doing small volumes. So that's how we're putting it into immediate use, to answer your question, is we're doing small volumes of items, let's say 50 umbilical cord clamps to go on the umbilical cords of newborn babies. We're doing, say, 50 of those a month. It's low volumes. The quality of those products on a 3D printer is good enough, and in some cases better than what is available, even through international supply chains, but certainly on the local market. The reliability aspect, we are using enclosed 3D printers and to deal with the issues of dust or disruption to the printing process, to the extrusion process. Sorry, we are running our 3D printers off car batteries. We might sort of drive into an IDP camp and hook up our 3D printer to the vehicle's car battery. Solar panel installations are something we're trying out in the next couple of months. But I mean, there's no reason why that wouldn't work. And I suppose the final part is actually the raw materials question, which is something I've already spoken about. We rely on, in the humanitarian disaster relief sector, people traveling in and out. I hope that makes sense, though. Small plastic parts that are available in low volumes is really where we're at. In terms of scaling up, we're looking at 3D printing molds for things that can then be made in larger volumes. I found the question from Karan Gupta, which is basically, he says he's interested in 3D printing and looking forward to career opportunity. Okay. Want to get into the technology in India for various purposes. There are some fantastic groups in India working on this, and I would go to a website called the Ananse group, ANANSE group, and on that website, a few of our colleagues and partners have. Let me see if I can write it into
the chat. Okay.
Chat. So if you look up the Ananse group, they have created a map. It takes a little while to load because there's a lot of entries on it. A map of maker spaces and fab labs and hacker spaces primarily in developing countries, and you can find out where your nearest sort of hub or makerspace is, and then start trying to network with the people in there. Increasingly, what's happening is that people from companies and universities are approaching these spaces to try and help with design of their own products. So depending on the nature of the place you're working with, that might be an opportunity. But they will also know about hackathons and makeathons. And I know recently in India, the International Committee of the Red Cross did something called the Enable Makeathon, which was looking at prosthetics with people who've lost their limbs in crisis situations, in warfare, conflict situations. And that was run in India. And, that's sort of run as a competition. So you could brush your skills up in the local makerspace, get used to the skills, and enter these competitions that you can then use to get noticed. I guess the other way to go is to speak to a manufacturer, a local manufacturer. Maybe your school or your family might know someone who makes things, and see if you can persuade them to give you an internship or something like that to help do a bit of research and development about how they might use 3D printing in their work. I know certainly there's a lot of hospitals in India that are interested in that work, not just manufacturers.
I think Karan mentioned earlier on that he's actually working in a startup which is manufacturing 3D printers in India. So he should probably have access to the hardware.
Yeah, absolutely.
So we had, Khalid probably just joined us late. He's interested in 3D printing in architecture. And then perhaps one last question, talking about the new developments in the multi-fusion printer from HP, which we've all heard about and they've finally launched.
Yeah.
Is that, relevant?
Yes.
In terms of...
Okay, so on architecture, first of all, because we've got a background in disaster relief, that's our main work. We haven't been getting involved in architecture. There have been a number of efforts to look at the use of digital fabrication technologies in the supply of, in actually making refugee shelters or emergency shelters. And there's some research groups looking into that. I don't think that will necessarily work. One of the fundamental concepts in disaster relief, or with refugee populations anyway, is that the shelters should not be permanent. So if, say, you are printing with concrete, that can look pretty permanent, and it does cause legal issues for some of the camps. There are, refugee camps like Dadaab in Kenya where no permanent structure is allowed. You're not allowed to kind of put any foundations down for any building. So you can only really build with wood and metal sheeting and plastic sheeting. The multi-fusion 3D printer, I'm really excited about. I can't wait to get our hands on one. And I think what we're seeing is an increase in speed, just like we had with traditional 2D printers, increase in quality and speed and color. The price is coming down. It's going to be more accessible. And what I'm worried about is that the business model might shift to, well, kind of like with the traditional printer at the moment, where you have to pay for the supply of proprietary ink, as it were, a proprietary filament or whatever it may be. So though the upfront cost of the printer might be low, the cost of the supplies, the materials that it uses might be high. And that's where I'm worried about that kind of technology, that kind of business model emerging, because I think that, again, concentrates the capacity to make things in the hands of a few companies, rather than distributing that to everyone, which is hopefully what the recycled 3D printed filament work might enable us to do.
Yeah. Well, Andrew, we'll close our discussion here. Thank you so much for sharing your thoughts. I think your message and perhaps we can share that. I mean, with this video, we'll be sharing that with all our learners inside the course. And so if any of them want to get involved with either Field Ready or your other, other projects, should we just direct them to your website?
Yeah, and my Twitter handle is @Andrew Lam, and my email address is andrew.lam@fieldready.org. Vishal, if you you put that in the chat.
Yeah.
Get in touch with me. I've learned a lot from what people are interested in anyway. I'm very glad that there are people all over the world interested in this, particularly from developing countries and countries that could potentially skip an industrial revolution or two.
Absolutely, yeah.
Using this kind of technology. And I'm really interested to go and learn a little bit more about 5D printing. I have to say that's new to me. So thank you to you and to your learners for the opportunity.
Well, thank you to all the viewers for joining, and we will share the recording of this video in the course. And I think I can also share the details of the chat with all the links inside the course as well. So, and if any of you are not in the course yet, you can find information. I'll give you our website as well. The last link, that's where you get information about the course. So thank you everyone, and we'll see you back in the class.